For decades, we've been told a very simple, almost reassuring story about depression and how to treat it. But in this explainer, we're going to take a critical look at that story. We're going to reevaluate the evidence for long-term antidepressant use, and we'll focus on two key areas: how well they actually work and the very real potential for medically induced harm.
So let's start with the foundation of this whole story. It's this idea that depression is caused by a chemical imbalance in the brain. And you know what? It's been incredibly persuasive. An estimated 85% of the public believes this is a fact. But is it? What does the actual science say?
So, Section 1, the foundational myth. Let's dig in and deconstruct this chemical imbalance story. We'll look at where it came from and whether the evidence actually backs it up. Now, this narrative, the idea that depression is just a lack of serotonin that you can fix with a pill, it really took off right as antidepressant prescriptions started to boom. And you can see why, right? It's a simple, tidy explanation for something that's incredibly complex and painful.
But here's the thing. This quote from a massive 2022 review that looked at decades of research is about as definitive as it gets. The science is clear. There is just no convincing evidence that depression is caused by low serotonin. It's simply not there. And look, it isn't just a few rogue researchers pointing this out anymore. Major institutions, like the Royal College of Psychiatrists in the UK, are now officially backing away from that claim. They're admitting that this core idea, the one that so much of modern practice was built on, was, well, a major oversimplification. Which brings us to Section 2, the efficacy reality check. And this leads to a really crucial question, doesn't it? If these drugs aren't fixing a chemical imbalance, then what are they doing? And how well do they actually work? Let's look at the data. This chart pretty much says it all. It's from Irving Kirsch's famous meta-analysis, which was huge because it included unpublished data from the FDA. And what he found was that, on average, antidepressants only offered a tiny 1.8-point improvement over a placebo, a sugar pill, on the standard depression scale. Now this is the key. That 1.8-point difference, it's statistically significant. That means in a huge study with thousands of people, you can detect it. But, and this is a big but, it falls way below the 3-point difference that's considered clinically significant. That's the amount of change a real person would actually notice in their day-to-day life. So really, what we're seeing is just statistically detectable noise. Let's put that another way. This brings us to something called the number needed to treat, or NNT. For antidepressants, that number is about 7. That means you have to treat 7 people with the drug for just one of them to get a benefit they wouldn't have gotten from the placebo. So what about in the real world, outside of a perfect clinical trial? Well, this is from the STAR-D study, the biggest trial of its kind. And the results? After one round of SSRI treatment, only about a quarter of people actually achieved remission. The results have been described, pretty bluntly, as miserably poor. And that really gets to the heart of the matter when you're looking at these studies. There's this huge gap between what's statistically significant, these tiny changes on a rating scale, and what's clinically significant, which means a real, meaningful improvement in someone's life. Section 3, the long-term consequences. Okay, so when you have this shaky foundation for how well these drugs work, it can lead to a kind of trap where keeping people on them for years can create a whole new set of problems. And this is something we call iatrogenic harm, harm caused by the treatment itself. See, when you introduce a drug to the brain for a long time, the brain adapts. It's smart. It tries to get back to its baseline. So while the immediate effect is a flood of serotonin, over time the brain compensates by making its receptors less sensitive. It basically turns down the volume, which can lead to the drug just not working anymore. And some of these harms can be incredibly severe and long-lasting. There's a condition called post-SSRI sexual dysfunction, or PSSD. This is where devastating sexual side effects don't go away when you stop the drug. They can persist for months, years, or sometimes they're permanent. This is a profound iatrogenic harm that has to be part of any conversation about informed consent. Section 4, the withdrawal challenge. So given that the brain physically changes to adapt to these drugs, what happens when someone tries to stop taking them? Well, then you have to face the reality of physical dependence. And the numbers here are pretty stark. Roughly half, 50%, of all people who try to stop taking an antidepressant will experience withdrawal symptoms. This isn't some rare side effect, it's a coin toss. You know, for a long time, the medical world used this very soft, euphemistic term, discontinuation syndrome. It sounds mild, right? Like it'll be over in a few days. But that language is finally changing. The correct term is withdrawal. And that word matters because it acknowledges the truth. These drugs cause physical dependence. Your body gets used to them and reacts, sometimes very strongly, when they're taken away. And the symptoms of withdrawal are not trivial. They can be completely debilitating. We're talking about things like brain zaps, these strange electric shock sensations in your head, crippling anxiety, and insomnia. And what's crucial is that official guidelines now admit these symptoms can be severe and can last for months, or for some people, even years. So how can someone get off these drugs safely? Well, the science points to a very specific method called hyperbolic tapering. It's based on how the drug actually binds to receptors in the brain. The biggest shock to the system comes from removing those last few milligrams. So the method involves making smaller and smaller cuts as the dose gets lower, giving the brain a fighting chance to readapt.
Okay, so Section 5, a path forward. With everything we now know, how do we move forward? What does this mean for the millions of people who are on these drugs long term? The only way forward is through informed, collaborative care. If you are someone on long-term medication, here are 4 concrete steps you can take. First, ask for a dedicated appointment just to review your meds. Second, talk about why you started them versus what your goals are today. Third, ask directly about the balance of long-term risks versus ongoing benefits. And finally, if stopping seems right, ask for a slow, evidence-based tapering plan. Ultimately, this kind of reframes the entire mission of mental health care, doesn't it? It suggests that real healing isn't just about tweaking brain chemistry. It's about human connection. It's about understanding someone's story and supporting them through times of incredible distress. And that really leaves us with the big final question. As the science changes, our challenge is to build a system that can hold both things at once, one that respects the scientific evidence but also honors the irreplaceable value of human presence, to find a path to healing that is not only effective but also deeply, profoundly humane.